Hello, sir. Hanish, sir.
Yes,
Hello.
yes, sir.
Hanish, sir, can you hear me?
Yes, sir.
We will start the
Yes,
session.
yes.
Sir. We will start.
Yeah. Okay. Fine.
Okay. First, I will give brief introduction, sir, and then
Okay, fine.
I will hand over the session to you, sir.
Okay.
So, good afternoon, everyone. Now we are moving on to the session 2 of our FDP revolution and advances in e-vehicles. So the session is about revolution of e-vehicles. So this session will be delivered by Mr. Hanish KM, Associate Professor, Department of Electrical Engineering, School of Engineering and Technology, Christ. So we just want to give brief profile about the speaker. He completed his BTech in Electrical Engineering from Calicut University, Kerala, and MTech in Electrical Machines from Kerala University. He is presently doing his PhD at VIT University, Vellore. His research areas include hybrid electric vehicles, battery management systems, and control engineering. He got more than 20 journal and conference papers for his credit. Mr. Hanish KM is presently handling projects in the e-mobility R&D Center at Christ University. He is also a certified energy auditor certified by Bureau of Energy Efficiency India and used to conduct energy auditing in various academic institutions. We are very happy to be that our resource person is here to deliver the talk about the revolution of e-vehicles. Once again, I welcome our resource person, Mr. Hanish KM, sir, to this session, and I will hand over the session to the resource person. Thank you, sir. Thank you for being here. Thank you.
Thank you. Thank you. Can you share the presentation? Okay. Okay, my screen is visible, no?
Not yet, sir.
Okay. Just. One second. Is it okay now?
Yes, sir. Now it is visible, sir. Thank you.
Okay. So, good afternoon. So, thank you for the nice introduction. Okay. So, myself Hanish KM. So, I'm working with Christ University, Bangalore. Okay. So, I'll be talking about the revolution of e-vehicles. Okay. So, actually, this 5-day, the national level FDP is on the revolution and advances in e-vehicles. Okay. So, and today I'll be talking on the very basic things. Okay, so we'll be talking on the electric vehicles. Okay, and the importance of electric vehicles and the how the future of electric vehicles, especially with some focus on Indian conditions. Okay, so and the hopefully some of the sessions already you attended, some of them already talked something. Okay, so I'll try to stick on to some basic concepts. Okay, I think I have one more session tomorrow, so tomorrow I'll be talking on the hybrid vehicle. So today basically I'll talk on some the electric vehicle aspects. Okay, so more generic. So you can if you are having any questions, you can ask any time in between also. So or you can ask at the end also. Okay, so the electric vehicle means basically it is using the electricity to propel the system. Okay, so to drive the vehicle, if you are using the electricity, that is what is known as an electric vehicle. So sometimes it will be from your vehicle inside. Okay, so all our cars, okay, all our the small two-wheelers, three-wheelers and all usually will be having battery inside. So that and then from there it is powered. Okay, Okay, that is an electric vehicle. Okay, sometimes the electricity can be supplied from outside also. Okay, usually in our trains. Okay, so we are using electrical engine or electrical motors. So usually we are getting the power from outside, so that is also we are calling electric vehicle. Okay, and the in generally when we are talking, so the hybrid vehicles also coming along with the electric vehicle. Okay, especially the country like India, we have, I mean, the only very less percentage of the electric vehicle presently. Okay, and we cannot the completely change into electrical vehicles quickly. Okay, because the you need to invest a lot. Okay, and a lot of technology is required. So what we'll do is we'll be slowly shifting into the electrical vehicle. So by going through some hybrid mode, that means, okay, in addition to your IC engine, present IC engine, will be adding some percentage of the electric motor so that your efficiency will get improved. Okay, so this is what all in the electric vehicle means. So it will generally when we are talking about electric vehicle, it may not be a pure electric vehicle, it may be sometimes the hybrid vehicle also. Okay, so that's what I just want to tell before when what I'm talking about the electric vehicle. So the contents are, so I'll be talking on why we are going for the electric vehicles. Okay, and we'll be talking seeing some bit of history of electric vehicles, because that is important. Okay, so what happened in the past. Okay, so there are some the interesting things are there. Okay, and what are the technological advancements came in the during the last the 40-50 years. Okay, and then some international regulations which is the compelling the people to move towards electric vehicles. Okay, and some the new EV policies in India. Okay, and what are the characteristics of the EV market in India. So this is the content of my talk today. Okay. Okay, so the we know we all use the lot of energy. Okay, so I mean for the bare survival of human being, you need around 2,000 calories of energy, okay, per day. Okay, but if you want to do additional task, or if you want to have more comfort, okay, you need to spend more and more energy. Okay, so the energy requirement is increasing. So we usually use, okay, the lot of additional sources for energy, okay, than our regular food. So we'll be mainly depending on the fossil fuel for the energy, because the that is giving the energy in a good quality and quantity. Okay, so the out of the total
Sorry to interrupt you. Hello,
yeah,
sir.
yeah.
Slide is not moving, or it has not given a slide sharing.
Oh, okay, 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 fine. I'll just
Kindly give slide show, sir. And
okay,
it is
okay,
not moving. Yeah.
okay, okay. One second. Or I can, what I'll do now, I'll, 1 second, I'll just
Okay,
share
sir. No
my
problem.
entire screen. I'll share. Is it coming now?
Not yet, sir. Screen is not sharing. First, screen sharing is off, sir.
Okay, okay. Is it coming now?
Yes, sir. Now it is
Oh,
visible. Yes,
okay.
thank you. Thank you.
Okay, sorry for the issue. Okay, so I was just giving the introduction. Okay, so uh, this is the my content of the talk. Okay, so actually, I mean in the total global energy use. Okay, so most of the 45% of the energy is going towards the industrial sector. Okay, then we have the lot of commercial buildings. Okay, so then after that the around 21% of energy is going towards the transportation. Okay, so the transportation means you have the road transportation, then you have the trains and even the aircraft. Okay, so Out of that, most of them, so around the 80% of them are the road and the rail transport. Okay, so out of transportation, so every year you have the, I mean, you require plenty of the fossil fuel. Okay, I mean, whenever you are using the fossil fuel, you will be having the greenhouse emissions also. Okay, so we have the most of our pollution is coming from this, the transportation sector. Okay, so you know, presently most of our the vehicles are using the internal combustion engine. Okay, where you'll use some petroleum products, so the petrol or diesel. Okay, so in the chamber will be compress it. Okay, so you'll burn it. Okay, so while burning you'll be getting the energy, and along with the energy you will be getting some emissions also. Some of the poisonous gases, also some of the greenhouse gases it will be emitting. So that is the present situation of our vehicular transportation. Okay, so the from your the IC engine, the internal combustion engine. Okay, there are a lot of pollutants coming. So along with the carbon dioxide, okay, you'll be having some amount of carbon monoxide, hydrocarbons, okay, some nitrous and sulfur oxides, okay, some particulated matter, the dust particles, okay, so which are more serious, okay, and some volatile organic components. Okay, so these are the main the gases which is coming out of the IC engine. Okay, and I mean, all these are causing the global warming, and some of them are even dangerous. Some of them will be causing even acid rains. Okay, so and some of them are producing the ozone at the lower level. So I mean, it is totally damaging the total atmosphere. Okay, as well as it is causing the global warming. Okay, so the transportation sector is the one main sector which is causing the environmental pollution. Okay, so we are using a lot of IC engines. Okay, we are burning the millions of liters of oil every day. Okay, so then the out of this the transportation, actually the road transportation is causing the more trouble, because the you can, even you are seeing the globally, so the road transportation is around consisting of around 80% of your transportation. Okay, so this is the context in which we are talking about the electric vehicles. Okay, so I mean the why we I mean where we are presently now. Okay, so your environmental issues are there. Okay, and in addition to that, you are the global oil reserve is the deteriorating, and the oil prices are going up. Okay, and I mean the countries like India, we are mostly depending on the import for the fossil fuel. So I mean, this is a context in which we will be talking on the electric vehicles. So I mean, we need to the move forward, because we need to reduce the pollution. We need to reduce the oil dependency. Okay, so that's why we are moving towards the electric vehicles. Okay, so before moving into the present context, we need to see some history of electric vehicles. Okay, so when it has come, so what is the journey of electric vehicle? So actually the electric vehicles were there even before the internal combustion engines were becoming popular. Okay, so actually the much before the internal combustion engines were becoming popular. Okay, so there were electric vehicles even in the 1900s. Okay, or even before that. Okay, so actually in the year 1900, okay, 28% of the cars in US were electric cars. Okay, so that is the that was the history. So around 20% of the vehicles in US were the electric vehicles. Okay, even actually that time the Woodrow Wilson, he was the president. He himself also was using some electric vehicle. Okay, so and there were a few electric vehicle companies were in US. Okay, something like the Baker Electric, Columbia Electric, Detroit Electric, and all. Okay, so they were there in the market. Okay, so they were the leading the market in 1900s. Okay, that is the early 1900s. Okay, But even before that, there were the attempts to start the electric vehicle. Okay, so actually the 1827 itself, they made the first the electric motor. Okay, so from the Faraday's principle, they made some electric motor. Okay, once you got your electric motor, then there were a lot of attempts to use that motor for some useful work. So that is why they have used in 1827. They used their electric motor to power a small car. Okay, so because once you get the motor, once you get the power, then there were a lot of attempts to utilize that one. Okay, so 1827, so around the 200 year back, so that powered the electric, the car by using the electric motor. Okay, then and there have been steady attempts to improve the efficiency of the vehicle, and that time the communication, the technical transfer was not easy everywhere. Okay, so there were different the innovations are happening in the different part of I mean, especially in the Europe and US. Okay, so in Netherlands, they made a small electric car in the 1835. Okay, then the problem is, okay, so how you will provide the electricity to the motors? Okay, you have some motor to drive the car. Okay, so you can use the wire to provide supply to that. Okay, then I mean, how you can do without wire? So that is how, I mean, that time the cells were found. Okay, the batteries were found. Okay, so they use the electric batteries. Okay, what are they available? But that time they all were the non-rechargeable batteries. You can use only once. Okay, so that they were using in 1830s. Okay, then they found a toy electric locomotive, that is for train. Okay, so in the 1835 they have used it for electric locomotive. Okay, then that were running at very slow. Okay, you can see that it is 6 km/h. Okay, so you imagine it is a train. Okay, so a 6 km/h itself per hour itself was a good speed that time. Okay, then there were a lot of attempts in the England and US slow quickly. Okay, because this news has come across in the US and the Europe. Okay, so there were few patents granted during that year. Okay, and that was happened in the middle of the 19th century by 1850 and all. Okay, then I mean, slowly they were doing a lot of innovation. They made it more smooth and more, they made it more efficient. Okay, so by 1900 there were a lot of cars commercially available in the market. So by the Baker Electric, Detroit Electric and all. Okay, so and they have started business with the electromotive vehicle in 1900. Okay, early 1900. Okay, but when it crossed the 1900. Okay, so it started the 1835 to 1900. Okay, so it was steadily improving. So by 1900, around 28% of the cars in US were the electric. Okay, then what happened parallelly is, okay, so there were the improvement in IC engine. Actually, the IC engine, internal combustion engine, so that picked up momentum. Okay, and I mean, once the Ford started the assembly line of cars, okay, the IC engine vehicles become cheaper. Yeah, IC engine vehicles become cheaper. Okay, so these are some of the early electric vehicle pitches. Okay, so and and there were also the locomotives. Okay, because the locomotives were easier, because especially the trains and all, because you can use the wired connection. Okay, you can have the personal the electric train light, so it can touch the line and go. Okay, so that's why the electric locomotives were more popular that time, because that is comparatively easier. You need not recharge it, you need not the stop for the charging. So whenever the electricity is there, you can continuously run it. Okay, so I mean, actually the electric trains were using from that time itself. Okay, so by early 1900 itself. Okay, so you can see there are a lot of models. Okay, and actually not only for passenger vehicles. Okay, they were using it in the mining. Okay, especially in the mining, if you are using the IC engines, okay, they'll consume oxygen also. Okay, but if you are using some electric vehicle, so it can easily use without the consuming oxygen. Okay, you can see some designs, okay, which are just touching the lines and giving supply to the mine vehicles and all. Okay, and there were many designs of the the locomotives there. Okay, so that time itself the locomotives were popular. Okay, so there were plenty of models. Okay, especially in the age. So that is the age when the civilization started the mining operation. So a lot of the industrialization slowly started. Okay, so all that the trains were helping in the transportation of the mining goods. Okay, and also the passengers. Okay, then that was a golden age for the electric vehicles. Okay, then what happened, then the IC engine become cheaper. Okay, so there were a lot of issue with the IC engine. Okay, so the IC engine was not self-starting. Okay, then they found the electric starter for the IC engine by 1912. Okay, and also they have some the improvement in the efficiency, the smokes and the emissions were reduced. Okay, so and by the 1930s, okay, actually the lot of companies came forward. Okay, and they started making the lot of IC engines. So in the market, when you are comparing the IC engine vehicles and electric vehicles, so the IC engine vehicles started getting the edge over the others because that can run longer distance. Okay, so you can refuel it. Okay, or you can have some fuel stations. Okay, so unlike the electric vehicles they can run only a limited range. Okay, after that you need to recharge the battery. Okay, so slowly the IC engine vehicles become more popular. Okay, so this is the estimate number here. Okay, so around 1.32 billion cars and trucks are there by 2016, and it is increasing at a higher, bigger scale. So presently you will be having lot of IC engine. Okay, and if you are taking the across the globe, okay, only 2 million electric vehicles are operating today. Okay, so this is the data from the last 2020 end. Okay, so around 2 million electric vehicles are operating across the globe. Okay, but it is just 0.2% of the total vehicles on road. Okay, so this is a global number. Okay, so we have only 0.2% of electric vehicles running now. Okay, so actually in 1900s we have around 28% of the vehicles were electric. Okay, but then the around 100 years, okay, it was for the year of the IC engine. Okay, so there were the mostly IC engine. It could outweigh all other options. Okay, so only 0.2% is electric now. Okay, so but what is happening during that 100 years is, okay, so the technology were slowly getting up. Okay, so there were a lot of issues with the electric vehicle. Okay, that is why the IC engines got the advantage. Okay, so they invented the MOSFETs were invented in 1959. Okay, because the MOSFET is the one which you can switch on and switch off faster. Okay, it is for fast switching. Okay, and then there were the invention of microprocessors happened in 1971. Okay, so you can do a lot of control by using a single chip. Okay, on the board itself. Okay, so that enabled the easier control. Okay, then the IGBTs came, so the insulated gate bipolar transistors. Okay, so which are easier to control the induction motors. Okay, earlier you could have used only the DC motors because you have some battery that is DC. Okay, from some switching, then you are powering your DC motor. Okay, but this invention of these IGBTs, the giving you a chance to run the induction motors. Okay, the induction motors are much more easier, much more the efficient, and much more rugged design. Okay, so that if you can run the vehicles with your induction motors, okay, so that will be much more advantageous. So these things were happening parallelly. Okay, so and then the battery technology also, batteries were also, it was going slightly slowly, okay, because earlier days we were using the non-rechargeable one, but even though we started using the lead acid batteries and all, which are rechargeable, okay, but the lead acid also, a lot of the issues are there, which are heavier, okay, the power density is less, okay, the charge density is less, okay, but then came the lithium ion batteries. Okay, so presently most of you will be having some 5-6 batteries at home. Okay, in all your smart devices like your smartphone, laptop, or your clock, watch. So even the shaving braces, everywhere we are using the lithium ion batteries. Which are very compact, which will be giving much more life. Okay, and the very easy to charge and discharge. Okay, so the lithium ion batteries are becoming more popular. Okay, actually it started in 1985. Actually, 3 years back, the inventors got the Nobel Prize for the lithium ion battery technologies, because while the recommending them for the Nobel Prize. Okay, so the committee suggested that because they made the world more mobile. Okay, so you can you can be more mobile. You need not require much wired because of the lithium ion battery technology. Okay, so actually the commercially the commercial lithium ion battery was developed by the Sony in 1991. Okay, so and compared to the batteries, okay, so they are having the much more energy density. Energy density means in a specific weight, okay, you can have more energy, okay, and higher volumetric energy density. In a small volume you can have more energy, okay, and specific power density. Okay, so you can have more the energy storage in a smaller place. Okay, so and it is dry. Okay, so usually the lead acid batteries are wet batteries. Okay, you need to replace the acid and they are heavier. Okay, but lithium ion batteries are dry, rechargeable. You can have more number of charging, discharging, okay, than the regular batteries. Okay, so that is the another change happened during the 100 years of time. Okay, so that is the last 100 years. Actually, it was the age of IC engine. Okay, but by that time the global scenarios changed. Okay, it changed a lot. Okay, because last the 100 years the human the civilization was the using or developing quite fast. Okay, so the population the multiplied the by the huge amount. Okay, so they were the everywhere on the globe, and there the utilization, energy utilization has increased much higher. Okay, and by that time, so we are after 100 years when we are looking back, you could see that the something really bad is happening, or the global warming is happening. If you are seeing the map, you can see that the last at least the last 50 years, the global temperature is going up to around 1.5 degrees increase the average temperature rise. Okay, so because of that, you have the lot of climate changes, lot of the change in wind pattern, lot of change in the normal climatic activity. So this is happening. So then we have found out the reasons for it. Okay, so we are having a lot of the emissions happening. Okay, and the lot of greenhouse gas emissions happening. Okay, because most of our energy is coming from the natural resources, that is the fossil fuel. Okay, you have the utilization of coal, oil, natural gas. Okay, so all these are the increasing with the usage. Okay, so we have lot of direct emissions. Okay, So direct emission means when you are burning the fuel, that emission is directly going. Okay. And also we have the secondary emission or the indirect emission like that. Okay. So once you are burning the fossil fuel, you are getting electricity and you are using it. Okay. So the secondary emissions also happening. Okay. So these are the main reasons for the global warming. Okay. And the contribution by the transportation sector. Okay. So you see the country like India. So most of our vehicles are running with the fossil fuel. Okay. So I mean the daily the millions of liters of the fossil fuel is burned for the transportation. Okay. And all these transportation vehicles are emitting the greenhouse potential gases. Okay. So that is the one reason, main reason for the global warming. Okay. So once we identified these are the reasons behind the human and the global warming, then there were a lot of the realizations. Okay. And we have started discussing about the global warming, and we have started discussing about the climate change. Okay. And internationally countries came together to discuss this one. Okay. And there were a lot of the international bodies, organizations to discuss the climate change. Okay. One of them was the United Nations Framework Convention on Climatic Change, the UNFCCC. Okay. So actually that is the body, okay, under the UN, okay, United Nations, okay, where different countries are part of it. Okay. So they were started meeting regularly after the 1972. Okay. So actually the 1972 is the oil crisis happened. Okay. So after that they started the continuously meeting. So they identified this some serious issue is happening. Okay. So we need to slowly mitigate it. Okay. Then there were a series of the conventions. Okay. So every 5 year or 4 year they were conducting some meetings. Okay. The countries were discussing it seriously. Okay. And then finally they came up with some protocols. Okay. Protocols means some international regulation which all these countries they are part of here UNFCCC. Okay. They need to agree and they need to practice. Okay. So that is what is known as the protocols. Okay. So there were a few protocols. Okay. So the major protocol came in the Kyoto Protocol in 1997. Okay. Actually, that meeting happened in the city of Kyoto. Okay. So that's why it is known as Kyoto Protocol. Okay. So they identified some 6 major the greenhouse potential gases. Okay, like the carbon dioxide, the methane gases, nitrogen, okay, hydrofluorocarbons and all. Okay. So these 6 gases, the countries agreed to reduce their amount of the emissions. Okay. So all the countries are agreed to reduce the amount of emissions of these gases. Okay. So how you reduce this one? So different countries are given different targets based on the status. Okay. So some countries are developed countries, some countries are the developing countries. So for developed countries and developing countries, they have different targets. Okay. So the target is like, so you need to reduce your emission to your previous level. Okay. So actually it is a difficult task because now you are having more and more people and you are going to have more and more systems, more and more vehicles, okay, more and more equipments. Okay. But you need to reduce your pollution to previous levels. Okay. So that was the protocols in Kyoto. Okay, so you can see that different countries in EU and US they are having a tougher the targets. Okay, they need to reduce their emission to previous value. Okay, how they will reduce their emission? Okay, they need to follow certain standards. Okay, suppose in a country like India, you need to reduce the emission means government will take the decision to reduce it. So then they have to implement it. Okay, so every sector they need to reduce the emission. Okay, so that is how the different emission standard norms have come. Okay, so the latest one is for the vehicles. It is the BS6 emission norms. Okay, so the BS6 emission norm. So I mean, all are talking about BS6. Okay, so basically it is to reduce the emission of the all the vehicles which are newly coming into the roads. Okay, so you can see that the previously we were having the BS4 standard. Okay, so in India we are not going for BS5. Okay, we are directly going for BS6 from BS4. Okay, you can see that the emission level, what is the nitrogen oxide limit, NOx limit. Okay, so earlier it was 80 milligrams. Okay, so now it is reduced into smaller amount. Okay, so your engine has to redesign, your emission has to be reduced, even the particulated matter. Previously there was no the limit. Okay, now you should not emit more than 4.5 milligram per kilometer. Okay, similarly the for diesel vehicle you have limitation. So all the the values are reduced. Okay, so this is how you will be implementing the laws for reducing the emission. So what is the source of your emission? That point you put the constraints. Okay, but this BS6 norms, it is not easy to implement. Okay, so you are trying to burn the same fossil fuel. Okay, so but you need to have less emission. Okay, so and the IC engines are came through a long way. Okay, actually more than 100 years of the innovation happened in the IC engine. Okay. So if you want to reduce the emission further, it is not easier. So you need to redesign the engine. You need to implement the some more additional components into the engine so that your emission value will be falling within this limit. Okay, so all these design limitations you'll be putting the vehicle become much more costly, because in order to put the vehicle the emission within this limit, you need to redesign, you need to add more components into the system. Okay, so it is not quite easier to implement all these norms. Okay, that is why they are also going for slowly going on the BS6 standard. Okay, but this has given a good opportunity for the electric vehicle. Okay, because if you want to reduce the emission, then instead of going for the IC engine, so you can shift into electric motors. Okay, so electric motor as such, it is not emitting anything, okay, any poisonous gases. Okay, but only the generation of electricity is producing the emission. Okay, so if you can shift into renewables, okay, that emission also will not be there. Okay, so that is again we started discussing about the electric vehicles. Okay, in a bigger scale. Okay, so to implement the international regulations on climate change and all. Okay, so the countries have come together. Okay, so each country have some EV policies. Okay, some the electric vehicle policies. Okay, so there will be some legislations. Okay, some laws will be there. You should not use the vehicles beyond the more than 15 years old, or if it is having more than this much emission, you should not use. There will be some legislation. Okay, and there will be some target. We'll be telling that by 2030 we'll be having some 30% of the vehicles on road will be the electric vehicles. So that are the some target. Okay, then we have some ambitions. Okay, so may not be completely achievable. Okay, but the governments and bodies will be having some ambitious targets. Okay, then we'll be having some proposals. Okay, so this is how usually every country has made the EV policies. Okay, some are becoming laws. Okay, so then everybody has to follow that one. Okay, and some additional target like suppose India has to reduce the emission by 5%. Okay, or you need to put your emission to the 2000. What was the emission in year 2000? You need to reduce your emission to that that level. Okay, so that are the targets. Okay, then you will be having some additional things. Okay, so the different countries came up with the policies for EV. Okay, so you can just have a look. So the European countries have a little more easier targets because they are getting the renewable energy easily because they have the more wind and solar potential. Okay, so you can see that the European Union, okay, so 15% of car sales by 2025, that is zero emission vehicles, okay, so by 15% by 2025, 35% by 2030, okay, so that type of targets they started putting, okay, so the even China, they have, I mean, their target is to reduce the fuel consumption by 14 to 16%. Okay, so from your previous stage, they are trying to reduce the fossil fuel consumption. Okay, and the 70% of passenger vehicles are electrified in 2025. Okay, and 100% by 2035. Okay, that is all the passenger vehicles, they are having the target to mean the completely shift into electrical by 2035. Okay, so we are in 2021, so next 14 years, so they have a target. Okay, so in India also having a lot of ambitious targets. Okay, so we have some projects. Okay, so we are having a target of, by 2022 we have a target of 7,000 buses, okay, and the 5 lakh three-wheelers and 55,000 the light vehicles, okay, and 1 million two-wheelers will be trying to shift into electric. Okay. Okay. So, and also we are trying to reduce the carbon dioxide emission. Okay. So actually this is not easier to achieve. So we have framed some the the targets, okay, some the ambitions, okay, and then we are putting some laws to reduce that. Okay, so and that is the state policy. Okay, and we have, actually India has developed some more policies. Okay, so we have a national electric mobility mission. Okay, so that is what is known as NEMMP, that is the National Electric Mobility Mission Plan 2020. Okay, actually this particular plan has started in 2013. Okay, so and under that they have started some project known as the FAME phase 1. So you would have heard already. Okay, so the faster adoption and manufacturing of hybrid and electric vehicles in India. Okay, so hybrid and electric vehicles, okay, how they can accelerate. Okay, so what are the things we can do to accelerate the adoption of electric and hybrid vehicles. Okay, so that is what is the FAME projects. Okay, the FAME plan. Okay, so how you can improve the electric vehicle adoption. Okay, so one is the demand creation. Demand creation means, okay, so more people are trying to buy the vehicles, electric vehicles. Okay, how it can be done? You give some tax benefit, you give some the registration benefits, you try to give some incentives. Okay, then the people will try to buy that one. Okay, so one is that one, demand creation. Okay, and the technology platform. So you, I mean, you reach out to the manufacturers. Okay, so you give some offers for the manufacturer, those who are the manufacturing these electric vehicles or the electric vehicle components. Okay, so that is the technology platforms. Okay, then some pilot projects. So government itself is taking some initiatives in some pilot projects, or they were helping some OEMs in developing some new products. Okay, then on the charging infrastructure. Okay, so developing, because whenever you have the vehicle, so you need to have regular charging infrastructure. Otherwise, you mean the people cannot move the far from the place. Okay, so and these are the things under the FAME phase 1. Okay, so actually it has started in 2015. Okay, so the 4 year it was running the phase 1. Then they started the phase 2. That's the continuation of that one. So with some additional the things. Okay, so actually here they are given more. I mean here some more realization scheme. Okay, in India you cannot directly jump for all the 4-wheelers or bigger vehicles. Okay, so the easier target is the 2-wheelers and 3-wheelers. because there you need to invest less, okay, and the people will be having the less burden of shifting from the IC engine to the electric vehicle. So the two-wheeler and three-wheeler market, basically they were targeting through the FAME 2 project, okay. So actually they have given more offers for the subsidy for the electric vehicles, I mean electric two-wheelers, okay, and also some discount for the two-wheeler manufacturers, okay. So that's why you can see that in India now more three-wheeler and two-wheeler the electric vehicle companies are coming up. So that is because the government policy is there, okay. So the government is supporting them, okay, so that they are getting some benefits. They are getting some incentives, okay. So that surely will be passing to the customers, okay. So more and more customers will be coming to buy these electric vehicle products, okay. So it is not stopping with the FAME project, okay. So different departments, okay, so concerning into the transportation sector has come with the different support schemes, okay. Actually the Ministry of the Power, so they are the responsible for the electricity supply and all, okay. So they have given some additional incentive for those who are setting up the charging stations, okay, and the charging station doesn't require a license now, okay. So they are giving the ECL approval for the charging stations, okay. Then the Ministry of Road Transport and Highways, okay, so usually we are registering the vehicle and all, okay. So they have got the green license plate, separate license plate for the electric vehicle, okay, and that means they are getting less the tax for that vehicles, okay, and they are getting much more benefit there, okay. So the people will be getting more motivation to buy the electric vehicles, okay. Then the Department in Science and Technology, so they are basically into the research and development thing, okay. So they are trying to make the standards for Indian vehicles charging infrastructure. So presently there was some issue, okay, because the different companies are having different the standards for their charging stations, okay. So actually there is a need to the uniform, I mean they make it uniform, all the charging technologies trying to uniform. So that is they are trying to make the standards for the electric vehicle charging infrastructure. So the socket should be same, so I mean same socket can be used for different vehicle, okay, but it was not like earlier. So there were some mismatch, so different the configurations were for different companies, okay. So the same charging station you cannot use for different vehicles, so that is the uniformized, okay. Then the Niti Aayog, so earlier I mean that they are responsible for the planning and execution of different projects, okay. So their aims to create a phased manufacturing program, okay, to support the large scale the competitive integrated batteries and cell manufacturing, okay. So India, we don't have much the battery manufacturing. Okay, most of our batteries are imported. Okay, so we don't have much battery units. Okay, so we need to support some industries. So those who are taking up these projects on the battery development. Okay, so that is what they have done through the Niti Aayog. So they have given some support for the battery manufacturing companies. Okay, and the support will be continuing for a few more years. Okay, so these are the policies from the national level. Okay, so from the central ministry, these are the main initiatives come. So there are a lot of the details for it. Okay, so the industries will have much more support from this. Okay, so the suppliers, all the different sectors they are given different support, okay. And I mean under this all the states and union territories, okay, so we have all the states, they have started developing their own EV policies, okay, because in their state they need to develop the EV culture, okay. So there I mean actually many states started earlier, like the states like Karnataka, they developed their policy much earlier, Okay, but presently 27 states. Okay, so almost every states and union territories having some their own plans. Okay, for the EV policy. Okay, so it is. I mean, state-wise the conditions may be different. The type of transport may be different. The type of infrastructure may be different. Okay, that's why the states have come up with the different types of the proposals to support the EV vehicles, okay, the electric vehicles. Okay, some of them are to develop the demand. Okay, some of them are to change the policies. Some are to invite the investors. Okay, some of them are to support the industry. Okay, so different policies have come. Okay, so I'll just quickly show one or two. The Karnataka, actually, this is one of the state which came much earlier. Okay, so I mean, in 2017 they have started the electric vehicle and energy storage policy. Okay, so they are proposing 1,000 electric vehicle buses. Okay, then the 112 EV charging stations in Bangalore. Okay, so many of them already came in Bangalore. Okay, and the e-mobility startups, so they're supporting the lot of e-mobility startup. Okay, actually I'm sitting in Bangalore, so we can see that in last few years we could see many companies have come up in Bangalore in the area of the e-mobility or electric mobility. Okay. So similarly the other states are also come up with some. The Kerala has proposed to have some 6,000 e-buses by 2025. Okay, and then some the tax benefits. Okay, some road tax exemption, some toll charge exemption. Okay, so I mean the free parking, the free permits for free drivers. So I mean every side they are promoting it so that the people get motivated it. Okay, so and the different states. So one or two points I'll pick up from Maharashtra. Okay, so the incentives for battery recycling. So battery life is slightly limited, so you can have some 4 or 5 years of the battery life. Okay, after that you need to the recycle it. Okay, so the Maharashtra has come up with some incentive for battery recycling. Okay, then the Gujarat having separate the targets for the two-wheelers, three-wheelers, four-wheelers, and all. Okay, so in each state and union territories having their own the policies. Okay, so slowly all are coming with a lot more incentives. Okay, so this says that okay, you have lot of support from the government and lot of support from the regulating bodies in the area of the electric vehicle. Okay, so the support may be sometimes in terms of money, sometimes in terms of the materials you are getting, sometimes in terms of some tax benefits. Okay, so or some target, some legal issues. Okay, so this is how different states propose their EVs. Okay, so because of this you can see that the actually the number of registered the vehicles annually, that is they shooting up very fast. Actually the 2017, 18, 19 and all, you can see that. Okay, so the increment is around the 30-40 percentage. Okay, per year it was around increasing some 30-40 percentage the number of electric vehicles. Okay, and actually in the last year we have a decline in the number of sales. Okay, because we had in the lockdown, because of the pandemic, we have a drop in the annual the EV sales. Okay, so but we hope it is a temporary one, because the early trends in 2021 shows that there is a positive trend for the electric vehicle sales again. Okay, especially in the two-wheelers and three-wheelers. Okay, there is a big jump in the number of units sold during the early 2021. Okay, so this is some of the state-wise split up. Okay, so but you can see that the average growth is around 20-30 percentage. Okay, so and if you are seeing the market forecast. Okay, so there are many the people have done the market forecast. There are many companies are doing the market analysis, especially for the business investment and all. Okay, so And I mean, actually, we had an unexpected pandemic break. Okay, so around one and a half year. Okay, but still, and this is the latest revised one. So this is the Indian and the market forecast in the 2025. Actually, this came in 2021. Okay, is a revised one. Okay, so you can see that the two-wheelers. Okay, so two-wheelers next 4 years actually we are seeing some the 20 times hike in the number of the electric scooters, because you see the cost of electric scooter is now comparable with the normal scooter, okay, the IC engine scooter, okay, but the fossil fuel price is going up, okay, so the fuel is now presently around 100 rupees per liter, okay, so by comparing that one, so the EVs are becoming, I mean, the more popular, okay, so the two-wheeler sector is seeing a big jump. Okay. Then the e-rickshaws, e-autos, the three-wheeler sector. Okay. So that is also seeing a big jump. Actually, the e-autos are becoming more and more popular because they are moving in a smaller region, so they are not running some 100 or 200 kilometers. Okay. So within the city, they can run some 200, 300 kilometers. So then they can go for the charging in the same city. Okay. So there will be charging stations or swapping stations. Okay. So the three-wheelers are becoming the much more simpler with the electric implementation. So we are seeing a big jump, around more than 100 times jump by 2025. Okay. And then passenger cars. Okay. Suppose the within the city limits and all, lot of people are using the passenger cars, okay, so even if you are not running, I mean, long distances, okay, so e-passenger cars, it will be having a big market, okay, and then government policy is proposing a lot more e-buses, okay, so within the city they can charge it and they can use it, okay, so the charging will not be any issue for the buses which are playing inside the city. Okay. So this is the market which we are foreseeing some. This is the 2019 and 2025 analysis. You can see that big jump is happening in the areas of two-wheelers and three-wheelers. Okay. So in India, the present market is like this because basically because of the investment issues. Okay. So the passenger car is slowly picking up. Okay. But the two-wheeler and three-wheeler will be, I mean, jumping quite quickly now. Okay, so the in 2025, okay, so we have the will be recurring a lot more components for all these vehicles. Okay, the electric motors will be recurred, the batteries will be recurred, okay, and a lot of power electronic components, the controllers, okay, then the charging station. So the overall business is going to be around the 4.8 billion by 2025. Okay, so a lot more, I mean, investors will be coming into India, okay, and a lot more companies will be start trying to get some amount of this business to their companies. Okay, so this is the forecast of the Indian market by 2025. Okay, so we can see that there will be a huge demand for all these things. Okay, and this is the approximate the split up of that one. Okay, so actually here the bottom one is the BEVs and PHEV. That means the battery electric vehicle and plug-in electric vehicle. So that means you are just plugging in and using it. Okay, then you have the hybrid vehicles. Okay, so the full hybrid vehicle and mild hybrid vehicle. Okay, so that will be having a bigger market because in Indian condition, okay, so we'll not be directly jumping into the electric vehicles. Okay, so you can modify the present IC engine vehicle, you can add some electric motor to it. Okay, so with less investment, then you can get better efficiency, you can run more kilometers with the same fuel. Okay, so that is the benefit of the hybrid vehicle. So the hybrid vehicles will be coming up in a bigger way in the next few years. Okay, so that is what the forecast is showing. Okay, and at the same time, the all other sector, the battery electric vehicle, plug-in electric vehicles, all will be increasing. So this is the projections which we are seeing. Yeah. So there are the forecasts. Okay, but I mean, all that things are not so easier. Okay, we have plenty of challenges. I mean, ahead. You know, if somebody is suggesting you to buy an electric vehicle, okay, so you will have some and the inhibitions. Okay, so something like the whether the vehicle is costly. Okay, so whether you'll be getting the sufficient charging station. Okay, or if I have some repair or maintenance, how I'll do. Okay, and the whether I'll be getting the batteries, how much battery life I'll get. Okay, so all these are the basic challenges which we are having. Okay, so I mean, the suppose you have a battery scooter, the electric scooter. Okay, suppose you need to travel some the 50 kilometers to your friend's home. Okay, and you need to come back. Okay, whether it will be running 100 kilometer. Okay, or in between the charge exhaust, what I'll do. Okay, so such questions we need to address. Okay, so that are the basic challenges. Okay, so whether I mean, we can get the confidence of the consumer. Okay, whether we can get the confidence of the, I mean, the confidence of investing in that electric vehicle. Okay, so some of the basic challenges or basic questions we need to address are okay. One is the high purchase cost. Okay, you know the still the electric vehicle cost is slightly higher. Okay, so even if you are seeing the two-wheelers, three-wheelers, okay, so compared with your conventional fossil fuel vehicle, okay, so these vehicles are slightly costly. Okay, so if you are comparing the electric cars, okay, so the normal electric cars, okay, so the four-seaters, okay, so will be coming around 10 lakh to 20 lakhs and all. Okay, so it is slightly higher than the our normal the fossil fuel car. Okay, then the issue of range anxiety. Range anxiety means okay, whether I'll be reaching there. Okay, suppose the vehicle, as per this vehicle specification, it will run some 100 kilometer. Okay, so suppose if I'm going 50 kilometer one side, okay, whether I can comfortably reach back in the next 50 kilometer, or whether I can find a charging station in between, or whether the car or vehicle will be stopped in between. Okay, so that anxiety will be there. Okay, so that is what is known as the range anxiety. Okay, whether I can get the sufficient running for my charge. Okay, so that is the range anxiety. Okay, then the lack of charging infrastructure. So that is a truth. Okay, so we are seeing a lot of the petrol pumps or petrol bunks near or every on our every highway. Okay, but we are rarely seeing the charging stations. Okay, actually in Bangalore city, slowly the charging stations are coming up. Okay, so if you are having the regular charging stations, then you'll have more confidence to run your vehicle. Okay, so presently we don't have a sufficient number of charging stations. Okay, so that is a big challenge, because suppose you are driving through a highway, you are traveling some 300 kilometers. Okay, whether you will be getting some charging station in between. Okay, if I am getting, so at what distance I'll get regularly. Okay, so that is a big question, the charging infrastructure. Okay, then the charging itself is a challenging thing, because you know the two-wheeler and three-wheeler will be having comparatively less amount of charge in their batteries. Okay, so you can, I mean, the charge them with a few hours. Okay, but the big vehicles like the four-wheeler, okay, or the big cars and all, okay, you need to the charge it for long hours. Okay, sometimes you need to charge it for the 5-6 hours to completely charge the battery. Okay, so that is not an easy thing, because you are traveling. So in between the battery charge exhausted, you need to wait for few hours to the again start the travel. Okay, so that is a big challenge. That is the one charging challenge. Okay, then the service and maintenance. So usually, I mean, whenever you are buying some new model of vehicle, so you'll be looking for whether I can get the service and maintenance. Okay, So same question is coming for the electric vehicle also, whether I can find some the service center nearby, or I mean I need to replace the entire component, or whether I can get it serviced. Okay, and the battery technology. Okay, so presently the batteries are costly. Okay, still. Okay, even with the lithium ion technologies and all, okay, still batteries are costly. Okay, still batteries are heavier. Okay, and the life of the battery is still the limited, because you can run comfortably some 4 5 years. Okay, so you have been using in your smartphone and all. Okay, same lithium ion battery we are using in the cars also. Okay, so the battery technology, I mean, we need to improve that battery technology. Okay, then the battery manufacturing capabilities. Okay, in India we don't have sufficient number of battery manufacturers. Okay, I already mentioned we have only less limited number of battery manufacturing capacity. Okay, and we are promoting them through some the policies. Okay, but still the manufacturing is very less. Okay, so most of our components we are importing from different places, or we are importing the cells and we are assembling here. Okay, and the now we are talking about using electricity to drive all your electric vehicles. Okay, so even though you are using batteries, okay, you need to charge the battery. You need to charge the battery. From where you will charge the battery? From the electric lines you need to charge the battery. Okay, so I mean this electricity, so presently all other the vehicles are running with the fossil fuel. Okay, so if you are shifting to electric vehicle, this much energy you need to again take from the electric lines. Okay, so that is a big challenge, because your electric power system is not capable of the delivering this much huge power. Okay, so you need to redesign your electric power. Okay, I think you have one more session on the grid integration. Okay, so you have plenty of challenges in the electric grid. Okay, so whenever you are charging whenever you are charging your small smartphone and all, okay, it is taking very small amount of current. Okay, but when you are charging a big car and all, okay, it is taking some the tens of amperes of current. Sometimes if you are going for fast charging and all, it may take 100 ampere and all current. Okay, so if you are having few the vehicles in a line, okay, so in the from the that line it is taking the huge amperes of current from the electric line. So we need to have the the bigger capacity for your the grid case. So you cannot have that much charging station with the present capacity. So you need to have separate lines. You need to have separate electrical the lines to support the charging stations. Okay, and one or two more challenges. Okay, one is the huge hydrocarbon based automobile industry. Okay, so presently all our the industry is basically based on the IC engine vehicles. You have the petrol vehicle, diesel vehicle. Okay, so most of our industry are the based on the automobile industry. Okay, and the shifting is not easier, because the company which is making the car, okay, so presently, so the IC engine vehicle, it cannot jump into an electric vehicle quickly, because the entire component is different, entire system is different. Okay, so you need to have everything separate. Okay, so the present industry is completely based on the IC engine vehicle. Okay, if you want to shift, okay, so you cannot do it quickly. So you need to have fresh investment. You need to have fresh systems to the build all these components in large scale. Okay, then the lifetime cost and disposal cost. Okay, so we have still question of the how much will be the resale value. Okay, usually when we are purchasing some the fossil fuel vehicle, you have some idea about, okay, so after 5 years if I am selling this one, I may get this much amount. Okay, or at least you have some rough guess. Okay, at least I will get this much amount, some 40 percentage or 50 percentage of my investment, I'll get it after my use. Okay, so that the estimation is there. Okay, so but in the EVs, the still that question is not completely addressed. Okay, also the battery disposals, okay, all that things are still a question. Okay, so whether you can the recycle the battery, whether you can replace the battery. Okay, so that questions are there. Okay, then the greenhouse gas emissions. Okay, so that is still a question. So even though you're using the electric vehicle, okay, so in the country like India, most of your the electricity is coming from the fossil fuel. Okay, you are having the thermal power plants. Most of our electricity is coming from the our conventional sources. Okay, around 60-65 percentage of Indian electricity is still coming from fossil fuel. Okay, so if you are not shifting into the renewable power, okay, so you will not get the complete benefit of electric vehicles. Okay, so I mean, even though you are using the conventional fuel for electricity, okay, if you are using the electric vehicle, you will get some benefit out of it. Okay, because of the electric vehicles having much more efficiency than your IC engines. Okay, so but if you are not shifting completely into renewables, you will not get the complete benefit. Okay, so these are the main challenges which we are facing. Okay, so the purchasing cost to charging to the battery to the resale value, all these are some serious questions the industry has to address. Okay, but and the some more technical challenges are there. Okay, so you have the charging station challenges. Okay, so we have only limited charging station now. Okay, but we need to have plenty more charging station. Okay, but these charging stations are not easy to install because you need to check whether the electric grid has the capacity to supply that much electricity. Suppose you have a highway running, so if you are keeping a few charging stations in the highway, and if you are regularly charging, whether the electric lines can they supply that much amount of electricity. Okay, so that charging station challenges are there. Okay, we are slowly addressing that one. So we are slowly the rescheduling our grid, okay, to supply these charging stations. Okay, then the I mean you see that the our electric towers, electric lines and all need to be carry more current. Okay, so we need to redesign all that things, or we need to have separate lines for the electric the charging stations. Okay, so the by 2030 we need to redefine our power system to support the electric vehicles. Okay, and the battery issues. Okay, so we have few issues with the battery. Okay, one is battery is costly, heavier, all that thing. Okay, so still all with all these things, okay, you need to charge the battery. Okay, so the generally the charging battery, presently we have two methods of charging. Okay, one is known as the regular charging or normal charging, that is slow charging. Okay, so if for a four-wheeler and all, it will take some 5-6 hours to completely charge the battery. Okay, so the that is a pretty long period. Okay, but and some fast charging options are there. Okay, so usually in the all the four-wheelers and all, the fast charging options are there. Okay, fast charging means it will take more current for charging, so that it will quickly charge. Okay, so that time it can charge within 1 or 1.5 hours. Okay, so that the depending on how much fast they are charging. Okay, so that is a fast charging option. Okay, but still it is a long period. Okay, suppose 1 hour for charging, I need to wait in a long journey, is a difficult thing. Okay, so there are the several other options, like we are going for battery swapping technology. Okay, so battery swapping means, okay, so I'll tell the battery swapping first. Okay, so the battery swapping means you are the suppose your the vehicle battery is getting exhausted, okay, you can go to the nearby station and you just replace your old the discharged battery with a completely charged battery. Okay, so you're just giving your battery there, and or they're taking your battery and they'll be giving you fully charged battery. So this will take only 2 minutes because you need to just replace the battery with a fully charged battery. Okay, so something like you are just replacing your gas cylinder with your empty cylinder, you are replacing with a fully the filled cylinder. Okay, so that type of charging station, swapping station, that is what is known as the battery swapping. Okay, so your the battery you are swapping with the fully charged one. Okay, so presently we have few swapping stations. Okay, so even in Bangalore we have few swapping stations for especially for the two-wheelers and three-wheelers. Okay, so you can go there and you can give your battery and you can take the fully charged battery. Okay, you need to pay for the charge, how much charge you are taking, so that much charge you can pay. So that is a good model because you need not wait for it. Okay, but you need to have sufficient number of swapping stations. Okay, and these swapping stations are difficult for bigger vehicles. Okay, bigger vehicles will have a bigger battery pack. Okay, to keep the bigger battery pack charge ready is difficult. Okay, so that is the battery swapping is the one technology which is the picking up very fast, okay, especially for the two-wheelers and three-wheelers. Okay, another one is the battery is costly. Battery is costly. Okay, so you need to the separate the ownership of battery from vehicle. Okay, actually the electric vehicles are costly because of their battery is also involved in it. Okay, so there is another proposal that okay, so you can buy the car separately and battery separately. Okay, so battery sometimes you need not buy, you can rent it. Okay, so you can rent from a separate company. So whenever you can take from separate company, you can put it. Okay, so that the vehicle cost will be reduced. Okay, so the ownership of the battery is shifting to somebody else. Okay, or you can take from some other company. Okay, so that the people will be more likely investing in that model. Okay, so and more competitors will be coming for the battery. Okay, so that is the separation of ownership of battery from vehicle. Okay, so you are buying the vehicle without battery, and battery you are buying from somebody else. Okay, and another one is the total cost ownership. This is another business model. Okay, so the actually the purchase, repair, service, all that things you are giving with a separate companies. So you have some service agreement with the separate companies. Okay, so that here the manufacturing company can disown all these things. Okay, other companies can they come into play in these areas. Okay, so the total cost of ownership, so that will be divided. Okay, so that is the another technology which we are coming. Okay, so out of this, actually the battery swapping is coming up very fast, especially for the two and three wheelers. Okay, so the EV charging station actually I mentioned. So basically we have the slow charging. Okay, then we have the fast charging, which will be taking much more higher current. Okay, so that two are the AC charging. Okay, and if you want the very fast charging, we'll be going for the DC charging stations. Okay, and you can see that in the coming days you will be having a lot more the charging hubs will be coming. Okay, and if you are using some renewable energy, it is much more advantageous. You need not burn the fossil fuel. Okay, you can reduce the emission. Okay, you can improve the charging. So within the cities and all, now few more charging stations will be coming up. Okay, and the I'll 5-10 minutes I'll finish. Okay, so the batteries. Okay, so the actually the battery cost is coming down. Okay, so we have mainly lithium-ion batteries. Okay, so the battery cost is coming up. Okay, because we are producing it in a large quantity and we have a higher demand also. Okay, So but we need to still improve the efficiency. Okay, so we are trying for some the new type of batteries, okay, the flow batteries, metal air batteries, and all. We are trying to have different technology, but still the lithium and lithium ion batteries are popular. Okay, and there are some other batteries also, the nickel cobalt aluminum oxide, okay, NCA battery, okay, then the lithium cobalt oxides, okay, then lithium manganese oxides, okay, the nickel manganese cobalt. So different types of batteries we are trying. So some of the new vehicles, the Tesla, Nissan vehicles and all, they are trying to have some new type of batteries other than the lithium ion battery. Okay. So in India, I mean, it is going to be, I mean, a bigger market for the electric vehicles because we have a huge the land area, we have huge number of vehicles. Okay, so but we are still having some hesitation in the areas of the, I mean, entire sector, but we are slowly picking up it in the two-wheeler and three-wheeler market. Okay, and the India going to be the fifth largest in the world. So, and it is slated to be the third largest by 2030. So that is the projection. Okay. So the idea is now we have the more opportunities in this area. Okay. So I mean your students will be getting a lot of opportunities in the area. Okay. So most of your students may be working in this area in the coming days. Okay. Or some of you are also may be working in this area. Okay. And we are the giving, I mean, this stress on the shared, connected, and electric vehicles. Okay, because we are, I mean, shared vehicles means the same electric vehicle you can share. Okay, so something like the Ola cabs, the Uber networks, and all. So you can have the shared and connected network. Okay, with the electric network. So and we need to tap our renewable energy, okay, for the generating electricity. Okay, so you cannot completely depend on the fossil fuel. Okay, you need to shift into renewable energy to get the benefit completely. Okay, and the annual growth of our market is around 36%. Okay, so every year your EV market is growing by 36%. Okay, so that is expected for next 5-10 years. Okay. Okay, and the India is giving a lot of the support for the battery manufacturing vehicle also. We have a national program on advanced the chemistry cell ACC on battery storage. Okay, so actually, I mean, in India we have comparatively less number of battery manufacturing unit. Okay, but we are giving a lot of the support for the companies to come up and the invest in this area. Okay, and you can see that recently a lot of the companies have taken up all this support. Okay, so the Tesla is coming into Bangalore. Okay, so the internationally they have the one of the biggest firm. So and the Ether Energy. Okay, so they are coming with the two-wheelers, and I mean they have already set up a lot of charging stations in Bangalore. Okay, and actually some of our students are also getting placed in the either companies. Okay, and the Ola Electric. Okay, so Ola Electric also coming with the two-wheelers. Okay, so I mean it will be hitting the market soon. Okay, and they are also recruiting a lot of students. Okay, actually last batch some of our students are got it in the Ola Electric company. So I mean they are, I mean, the getting into the market very fast. Okay, and the different states are setting up different targets so that the, I mean, the investors are going in all the states and they are trying to have pick up this market. Okay, and the some new companies are coming in this area. Okay, some startups are coming, some international firms are coming. Okay, and not only, I mean, this may not be a big companies. Okay, so there are a lot of smaller companies, startups also working in this area. Okay, so they are making some parts and components for the electric vehicles. Okay, there are a lot of scope for the electric, I mean, the design of the motor controllers, the batteries, battery charging controllers, the battery management system. Okay, so and then a lot of the app development, some the connected vehicle concepts. So the vehicle control, the charging station control, all that things are going through app. Okay, so the 2021 market, actually you can see that uh, the number of cars, number of buses and all, actually the increase. Okay, so the EV sales by the 2020, this was the number. Okay, actually the 2021, actually the number is slightly higher. Okay, so we are slowly moving out of the pandemic and the market is getting up fast. Okay, so the future of the Indian transport. Okay, so we'll be having much more electric vehicles than you expected. So I mean, you can see that your friends will be started buying the electric scooters. Okay, if they are not already started, so they'll be start buying quickly. So in city like Bangalore, we can see that I mean, when you are moving out in the road, you can see that many electric vehicles are moving around. Okay, many of the, especially the two-wheelers are, I mean, a big hit. Okay, so many more companies are coming in the two-wheeler and three-wheeler sector. Okay, so this is going to be the future of the transport in India. Okay, and there are a lot of investment options. There are a lot of the technology options. Okay, so the many more job opportunities are, I mean, already creating in this area even during the pandemic. So they are recruiting people and they are working for the, I mean, benefit of in the. So in India, coming years we'll be seeing a lot more the charging stations on the road. Okay, you can see a lot more electric vehicles around. Okay, so these are the some of my references. Okay, so and I have tried to make it more generic than the including much technical things. Okay. Okay, so thank you, my colleague, the Parag Jose, who was working with me in the electric mobility lab. Okay, so the Professor Dhruv Kumar in the government polytechnic Harpanelli for his coordinating the things. Okay, and the e-mobility R&D center in the Christ University for giving the support. Okay, and thanking all the organizers for giving me an opportunity. Okay, so now if you are having any questions, you can ask. Over to you, sir. Yeah.
Hello.
Yeah.
Hanish sir?
Yes, sir. Yeah.
Yeah, thanks for the...
So any questions you have? Anybody? Yeah, actually, I was trying to make it simpler. So it's the afternoon session, 2-hour session, I know. So any questions anybody having, then you can ask. So, but otherwise we see, I mean, the lot of opportunities in the area of electric vehicle. Okay, so I mean, what is my proposal is actually, I mean, don't hesitate to do the work. Actually, from our experience, what we are seeing is, okay, even the students doing some small development, the projects and all in the campus. Okay, now they are getting placed in some good companies. Okay. So those are trying to make some the e-bicycles. Okay, they are trying to make some the charging controller for the batteries, some battery technology, battery swapping technology. Okay, even though they have some idea about all this technology, there are the companies around, they can get some job in this time, because there is a requirement for the people in this area presently, because the no colleges are offering direct courses in the electric vehicle. Okay, so I mean, those who are having some experience in doing the things, not the theoretical, but knowing the things and by doing, so doing some projects or something. So, and I mean, they are getting the opportunity. So that is what is our experience in our campus. We are having some labs. Okay, so those who are working with the electric mobility in the area, they are getting some job in that area. Okay. So some of them are placed in either Ola, electric, and all. Okay. So similarly, you can also take up some simple projects, some developing some controllers for the electric motors or electric vehicles, some small projects. Okay. So that you can support your students or you can support yourself, okay, and trying some the experience in this area. Okay, so this is a good open area, so you can the lot of startups also there. Okay, all are looking for some people who can really work with this. Okay, so not theoretical things, some hands-on training if they have, so then there is a good chance to get some opportunity now. Over to you, sir.
Thank you, sir. Mr. Praveen Kumar Budihal has raised his hand.
Yeah.
Professor Praveen Kumar, you have any question? Praveen Kumar Budihal. Okay, it seems no question. Sir, myself, I have a question.
Yeah. So,
At CRISE R&D Center, you're working on any particular battery material, like for anode, cathode, or electrolyte kind of material?
no, actually, we are not working in battery chemistry. Inside the battery, we are not doing. Okay, so we are doing with the battery management systems. Okay, so we are basically we'll be trying to find the SOC calculations, SOH calculations, and I mean presently we are trying to have some cell balancing and all. Okay, but we are not doing anything within the battery chemistry side. We are not doing. Okay, so what we do is we procure the battery cells and we assemble it as battery packs. Okay, some and outside the battery, how will be controlling the charging, discharging, the temperature control, the cell balancing and all. That part we are doing, not inside the battery. Okay.
Yeah, and at present, with the latest battery technology, what is the highest number of cycles which we can?
Yeah,
You have any idea?
yeah, actually, presently, we are using the mobile phones and all. Okay, so
Yeah.
actually the lithium-ion batteries you are using it for some 3-4 years. I think presently most of the your smartphones and all getting some 3-4 years without any issues. Okay, so if even if you are daily charging, you can get some 2,500, 3,000 cycle easily. Okay, so the lithium-ion batteries and all, we are getting that much cycles easily. Okay, and if you want more number of cycles, so you need to have more, the better batteries. Okay, but comfortably it will run for 5 years. Okay, so normal our lithium-ion batteries it will run comfortably for 5 years.
Yeah. In fact, when I gone through the research paper, the very hot topic is the degradation of batteries.
Yeah, so the degradation of battery actually, if you are having a good the battery management system, okay, so the degradation is not that much. Okay, so if you are, the degradation happens when the different batteries in a particular battery pack is charging and discharging separately. Okay, that is creating local heating, all that issues. Okay, so if you are having a good battery, good battery management system, the life is getting better. Okay, so that's why you need to have a better battery management system. Okay, so, but you can see that the whatever you are doing in the smartphone, the same thing we are scaling up and doing it in other areas. Okay, so slowly, the technology is same. So it is now more reliable technology. Okay, so it is now easier. So it is not a big technical challenge now. So you can, and now you can the what we are trying to do is we are trying to the estimate it earlier itself. Suppose after some 4 or 5 years your battery may go down. Okay, so if you can predict much earlier, then it will be good. So that is why the state of health also we are trying to monitor now.
Yeah. Thank you so much, sir.
Yeah,
Yeah,
thank you.
and dear participants, if you would like to interact with the professor, uh, the stage is yours.
Okay, so I mean, actually, my suggestion is in your campus, you can give some small projects for the students in the area of battery vehicles, battery management system, or they can do something with the electric vehicles and all. Okay, so I mean, most of the items they can procure from the market and also it is most of the even during now, so we can procure most of the items online and all. Okay, so if they are having some good experience or I mean good hands-on training on these things, okay, so there is a better chance to get some good the company placements. Okay, so you can try that one. Okay, and that is how we are developing because it is not only the big companies are working in this area. Okay, so this area is more open now. Okay, and even the smaller companies, smaller techniques also have some options. So you can suggest your students to try something. So or you can also do some research in area. You can support your students also. It's a good area and plenty of options you can do from battery management system, the charging, discharging, then the electric motor controllers, okay, control design. So plenty of areas are there. Okay. Even the app development, all that things. So many areas are there.
Okay, thanks for the nice session, sir. Fundamental aspects were thoroughly explained. Anyway, we have one more session from your side that will
Yeah.
be on tomorrow.
So tomorrow I'll try to have some bit of the some hands-on something. Okay. So I'll show some experience or something. Okay. Because the talking is slightly boring, especially afternoon. Okay. So
Yeah, that's good, sir. That's good. Thanks for that.
thank you.
And participants, if you have any questions, again, we'll have one more opportunity to interact with Professor Hanish, sir, by tomorrow. So if you have no other questions, I think time to end up the today's session.
Yeah, I mean, you can reach out us also. So, I mean, if you are having anything in coming in Bangalore or something, you can visit our area. So, presently, we are not completely in the campus. Okay, so we are still online classes and all going on. But I mean, if you want to see or if you want to do some projects, you can contact us. So, we'll try to help you.
Yeah, thank you, sir. I think
Thank you.
we still have a lot of opportunities for collaboration with you.
Yeah, yeah. So.
So
So
if
we are
any,
also open. So once we get permission, so we can try. So you can, if you are having
yeah,
any projects or something, so we can try to help.
thank you so much,
Thank,
sir. And
thank you all. Thank you
we'll
for.
we'll reach you once again for any further kind of information, models, or the latest research that is going on at your center. So thanks for the session, and happy that we'll have one more opportunity by
Yeah,
tomorrow.
we'll meet tomorrow again then.
Yeah. Dear participants, thanks for your active participation. And on behalf of Government Polytechnic Harapnalli and the organizing committee, and on behalf of all the participants, I would like to extend a sincere thanks to Professor Hanish KM for accepting our invitation and delivering a very nice and informative session. Thank you so much, sir.
Thank you all the participants. So we'll meet again tomorrow. So then,
Yeah.
till then,
And
bye. Yeah.
and there is one announcement for the participants. For today, we are closing the session, and by tomorrow we have session.
Okay. Okay then. Thank you.